Hello, welcome to another lesson. In this lesson we're going to start Unit 3. We're going to be dealing with trig functions with any angle, and specifically the signs of those trig functions. So they have a plus or a minus sign depending on the quadrant that they're in. And then we're going to be dealing with reference angles. So let's get right into it. First things first, in the last unit we found that if we were looking for this r, okay, that was some distance from the origin, this being the origin here at 0, 0. So we have 0, 0 here, and we had this idea of standard form where you have this positive x, and then you have an r being the distance from the center to the arm, or center to the point, I should say, from the origin to the point that we're talking about. But we never got into the other three quadrants when we dealt with angles. But it turns out that it's really important that we start thinking about that. So this is our x-axis and our y-axis. This would be our positive x values and our positive y values. So in here we have positives, okay? We have positive x and positive y. If we go the other way, we have negative x values and negative y values. So another way of looking at this is if we think about our coordinates x and y, well, in this case we have a positive x and a positive y. To the left here, you'll see that if a point exists in this space, we have a negative x value and a positive y value. Here we have a negative x value and a negative y value. And here we have a positive x value and a negative y value. So I would pause the video and try to make sense of that. Or for example, if you had a point over here, you have to go right, so you are in the positive x direction. You have to go up as well, so you're in the positive y direction. And so that's where my signs are coming from, pluses and minuses. So that's the basics that we're going to start with. We're going to be comparing this or matching this up with sines, cosines, tans, all that stuff too, but this is the main idea. Specifically, the signs of the trig functions depend on the location of the terminal side of the angle in standard position. So it depends on the quadrant that we're in. Or put even simpler, sine, cosine, and tan, when you evaluate an angle, will spit out something positive or negative depending on the quadrant. So I'd like to just go through some reference stuff. First of all is the first thing I showed you. It shows you pluses, minuses, and the appropriate quadrants. You might want to remember that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. The next diagram here tells you the quadrants like I just did. And then the next one is this weird C-A-S-T, which it turns out we're going to be reading it in this direction, okay? If you read it in this direction, it says cast. So let me make another diagram here, which you should write down yourself. I'm just going to put it at the bottom of the page, just because there's space here. I'm going to make my quadrants again. All right, these are my x and my y directions, y and x respectively. And I'm going to write down cast. So C-A-S-T. What this means is if we look at our trig functions, it'll tell us which functions are positive in which cases. So by this I mean all of our trig functions, no matter what is evaluated, are positive in the first quadrant. If we go into the S quadrant, you'll see that sine and cosecant are positive. Why sine? Because sine matches up with this S. By association or by extension, that means that cosine and secant, which are related, are negative. Tan and cotan are also negative. So anything that isn't positive will be negative. In the third quadrant here, so I should probably just remind you, this is quadrant 1 in this corner. Quadrant 2 is over here. Quadrant 3 is over here. Quadrant 4 is over here. It says T. That means that tan, and by association cotan, are positive. Everything else is negative. So if you know that that's true, then we know that sine and its friend cosecant must be negative. Cosine and its friend secant must be negative. And finally, in the fourth quadrant here, because it says C, that means that cosine and secant will be positive. And by extension, sine and cosecant negative, tan and secant will be negative. So again, this is called the cast method, or it's just a way to remember. We go C-A-S-T, that reminds you what's positive where. And I recommend that you read it this way, and you can remember that it's cast. But you might still be confused, wondering, what the heck are you talking about? How are we going to use it? So let me get to some more specific examples. But keep that cast in the back of your mind. This is just a reference. This is some reference info at the top of the page, which reminds you basically what I just said. And you can reread it, but it says an angle will have a positive cosine in the quadrants where x coordinates are positive. So positive cosine in the first and fourth, positive sine is in the first and second, and positive tangent is in the first and third. We can double check this. If we were to think about just the quadrants, well, this is CAST. So of course, cosine is positive in this one and in the one that has all of them. If we make another one, CAST, and we're looking for sine, well, where is sine positive? Sine is positive over here and in the one that has all of them. And finally, tangent. Where is tangent positive? Well, tangent is positive in the all quadrant, quadrant 1, and then down here. So again, something to remind you what's going on. You might not know how to use it yet. We'll get to that. But use this as a reference to remember where your signs are positive. So let's get to the gist here. Example 1, determine the sign, positive or negative, of the following functions without using a calculator. So first things first, this is a sine function. So if you're given a sine function, you want to know the sign that's going to spit it out. If we used a calculator, what would spit out of this? A positive or negative. You can just remind yourself, okay, cast. Well, here and here are where we have positives, right? So I'm just going to remove the cast because we know we should be thinking cast. And the angle 20, where's the angle 20? It's right here. We can see that this angle is in a quadrant where sine is positive. So the sign must be positive, or I'll say positive plus. All right? Sine in that quadrant is positive. Now I know that this said not to use a calculator. I'm just going to use a calculator to demonstrate what we're talking about. Sine of 20, close it. The number that it gives is a positive. You'll notice positive 0.34. So we're correct. It's positive, but we didn't have to use a calculator to get it. So let's do the next question. If you can do this in your head, that's great, but I just want to make a little sketch. The angle 200 is down here somewhere. Okay? You should know that. That is in the third quadrant. Sine is only positive in this quadrant and that quadrant. Sine is not positive in these two. So the sine is not positive in that quadrant. That means it must be negative. And so we say it's a negative, okay? And just say negative like this. I'll do one more. Tan of 20, 20 degrees is in the first quadrant. In that quadrant, everything's positive. Tan is also positive in that quadrant if we needed to. But in this case, we're fine. We know that it's in the first quadrant. We know that things are all positive in the first quadrant. So we can say that this is positive. Okay? So I would take a moment, pause the video, try to do D and F, and see if you can get them. So hopefully you tried that. Again, these are ones that I wanted you to try. I'm just going to sketch out the one for tan 340. 340, the angle is in this quadrant. In that quadrant, we know that everything is, tan is not positive in that quadrant. So if it's not in a positive quadrant, it must be a negative that it evaluates. And remember, you can put in tan of 340 into your calculator. It will give you a negative value, and that means we're correct. But you should be doing this without a calculator. For F, we've got a cosine. So 2tan. 2tan is in the third quadrant. Cosine is positive. Remember, CAST, C and A, it's only positive in these quadrants, which means that this is a negative. Hopefully you're seeing what I'm getting at here. Now we haven't done E or G. Let's take a look at E now. E is giving us a angle of negative 120. So we go this direction, right? We go kind of in the clockwise direction, which is not standard. And the angle negative 120 is down here. Now, everything else remains the same. We know that cosine is positive in the fourth and the first quadrant. We're not currently in that quadrant, so this has got to be a negative that pops out. And you can check that on a calculator. Check cosine of negative 120 on a calculator. It's going to give you negative a half, so it's going to be a negative. Now, take a look at D, pause the video, see if you can get it. I'm going to write it out here with no explanation. So hopefully you can make sense of that. It's negative 150, which is in that third quadrant there. That's a quadrant where tan is positive, and so we can say that the angle is going to be positive. So I'm going to write you a little summary here just so you have something to remember this by. You don't need to write it down, but just something that you might want to write down just to remind you how to do this. Okay, so different ways to approach this problem, but the main idea is if you're going to determine the sign of the function, use cast first, have cast in the back of your head so that you know which quadrant is positive for the given trig function. So use cast to determine where the given trig function is positive, okay? Draw the angle and note its quadrant. So if your angle you draw is in quadrant 4 and it's a tan, you should know it's negative, right? Because it's not in a positive quadrant. And then you determine the sign based on cast and your angle. So the next section here, example 2, is going to be basically doing backwards of what we just did. Instead of looking for the sign, we're going to be given the sign. We got to figure out the quadrant. So in this first question, it's telling us that sine is greater than 0, so sine is positive. It's going to say that tan is greater than 0, which is positive. Okay, this means greater than 0, which means positive. All right, if it's the other way, this means negative. This means positive. Just something that's very important to keep in mind. All right, so I'll write that up there. How are we going to do this? Well, I like to make a sketch. Make your little sketch. You know you have C-A-S-T, cast. Those are where everything's positive. Sine, what are we given? We know that sine is greater than 0. So sine is greater than 0 here and here. Tan, on the other hand, is greater than 0 here and here. And the quadrant that we're looking for must be where they overlap, because both of these things are true. So as a reminder, determine where this mysterious angle is. Well, this mysterious angle gives a positive sine value and a positive tan value. This is our only option. And so in that case, the quadrant that it must be in is quadrant 1. Or you can just write Q1. Let's do another one so you can get a feel for this. Secant. Secant less than 0. Sine less than 0. So secant is negative, sine is negative. Let's draw our cast out. C-A-S-T. Now, secant goes with cosine. Cosine is positive here and here. Should make a different color for this. Sine is positive only in here and here. So we have a problem. I went for positives instead. It's a very common problem. We should probably be thinking where it's negative instead. Okay, so just as a very specific example, this is negative. And here, this is negative. Okay, so I'm going to get rid of the extras. Now that we have this information, we should be approaching this and saying, where would it be negative? So secant, just as a reminder, is very closely related to cosine. So first, let's say where cosine must be negative. Cosine is negative here and here. That's because it's positive here and it's positive here, so you do the opposite. So be careful. We kind of do the opposite. I'll say use opposite cast approach. Sine, on the other hand, negative, means that it's wherever it's not positive. So normally it's positive here and here, so we need to do the opposite. It must be negative here and here. And by doing that logic, this angle we're given must be over here because that satisfies both rules. So the quadrant is quadrant 3. If you forget where your quadrants are, Q1, Q2, Q3, Q4. Be careful that you don't mix it up with cast, because cast starts in quadrant 4. Or another way you can remember this, which starts in quadrant 1, all students take calculus. Now that's not always true, but it's true in general cases. And then ASTC, quadrant 1, quadrant 2, quadrant 3, quadrant 4. A, S, T, C. So if you want something to remember that goes in the order of the quadrants, there you go. Let's do a couple more. Cosecant greater than 0, cotan less than 0. So cosecant is positive, cotan is negative. Cosecant, can't spell today, cosecant is very closely related to sine. So anything sine does, cosine also does. Sine is positive here and here. Cotan is negative wherever it's not positive. So tan is normally positive here and here, which means I must go here and here. And finally, that means it must be in the second quadrant. For D, I recommend that you pause the video and give it a shot. So do that first, and now I'll do the answers. Cosine, positive. Cosecant of this angle is negative. Remember, cosecant goes with sine. Cosine is positive, so cosine is positive in the C quadrant and in the A quadrant. Cosecant is negative wherever sine is not positive. So I would think, okay, sine is positive here and here, but I'm not allowed to do that, so it must be here and here. And finally, this is where they overlap. This must be the quadrant where both rules, this one and this one, are both satisfied. And so we have quadrant 4. So that one can be tricky, but I hope you see it's not too complicated. It's a new way of doing things. And so I recommend that you maybe take a blank page and try to do these again and see if you can get them, because it's very important that you get an understanding of this stuff. All right, let's move on to page 4. In this case, we're going to be doing what's called finding the reference angle of any given angle. So one weird thing about trig functions is that you have multiple ways of saying the same thing, which can be very frustrating. But one thing the calculator does, and the reason it does it, when it calculates angles, it gives you only the reference angle, okay? The calculator only gives the reference angle. And let me give you let me show you what reference angle means with a little interactive thing. Okay, so here we have an example of a reference angle. The angle, the actual angle that we're used to is 203. That's measured from the positive x-axis, which is like standard. But the reference angle is actually just this 23. It's taking the closest x-axis it can get and measuring that distance. All right, so let me show you. In the first quadrant, our reference angle is equal to the regular angle. Like, there's no difference. The reference angle is always going to be equal here. But in the second quadrant, notice what happens. We know the angle is actually 129. It's saying, well, no. Let's just get the smaller version of that, less than 90 degrees, and make sure that that's what we use, just because it's less numbers to deal with. You don't really need to worry about how it works. You just need to know that it works like this. And look at this. The reference angle is always going to be your 180 degree turn, which is this full turn, take away the angle that you have measured from the standard. Okay, I'll give you the formulas for this in a second. If you're in quadrant 3, in this case, your angle is actually 225, but you can see the reference angle is saying 45. That's because instead of taking the whole thing, it's just measuring from the closest x-axis. This would be actually take your full angle and take away 180, and you're left with this little piece 45. And finally, if I'm in quadrant 4, if the actual angle is, for example, 315, all the way around, it's taking the closest x-axis and measuring from that instead. So again, all these angles, these reference angles, are only ever going to go up between 0 and 90. And the formula for this, maybe take a moment just to think about it. If you had all this whole turn, 360, and removed your big angle, 315, you would be left just with the little section, 45. And again, this is what this is trying to say. 360 minus that big angle we're talking about is always going to be our reference angle. So lots to think about there. I'm going to give you the formulas for this, okay? The formulas for reference angles. So I'm going to say that the reference angle has a special symbol, which is alpha. Okay, I'm going to give you the formulas here, but let me just read the text above. Reference angle. The acute angle, which means it's less than 90 degrees. So it's between, I'll just say less than 90 degrees here. It's always going to be this tiny little angle formed by the terminal side of the angle and the nearest x-axis. it's always referenced to the nearest x. It's either the positive or the negative x-axis, okay? Angles which have the same reference angle have the same value for each of the trig functions, except the signs may change. So we'll deal with that a little later. But in quadrant 1, quadrant 2, quadrant 3, and quadrant 4, we have different formulas for the reference angles. All right, and I'm just going to state them here and then I'll explain them. In quadrant 1, the reference angle is equal to the angle that we're dealing with, the big angle. In quadrant 2, the reference angle is going to be 180 degrees minus the angle that we're working with. In quadrant 3, it's going to be the angle minus 180. And then in quadrant 4, the reference angle is going to be 360 minus that full angle we're dealing with, that terminal angle. And let me try to make this clear with a few diagrams. Let's start here. I'll make 4 quadrants, 4 diagrams, talking about 4 different quadrants, okay? This is going to be one dealing with quadrant 1. If this is our angle, then we have our regular angle here, and we have our reference angle. They are equal, which is why in quadrant 1, our reference angle is equal to our regular angle. There's nothing surprising here. In quadrant 2, see if you can figure this out yourself, okay? Quadrant 2, what's the reference angle going to be? Well, if our angle is measured from the positive x-axis, then we need to take 180 and subtract that piece, and it's going to give us the remaining amount. And so our reference angle here is the remaining amount, which is why we see it's 180 minus our angle. We have this 180 turn, take away the angle that we have, that's why we're given the reference. In quadrant 3, we have an angle down here, so we're measuring from the standard positive x-axis. The reference angle only wants to be the acute angle to the closest x-axis, which is going to be this one, which is why we have the angle minus 180. Our angle is quite big, okay? Our angle is big. If we take away all of this 180 part, we're just left with this little tiny reference angle. So that's the idea there. Let me just be complete and say this is quadrant 3. For quadrant 4, if our angle is down here, we measure from the positive x. That's a huge angle. Our reference angle is going to just be from the closest x-axis here. So that's our reference angle. This is our full angle. Take a moment to see if you can figure out what that reference angle's got to be. If you take a full 360 and take away all of this, you're left with only the reference angle here, which means it's the full angle, the full turn 360, take away our angle. But take time. I recommend you pause the video here, take 5 minutes, 10 minutes, 15 minutes, whatever it takes to make sense of these formulas. You can always use the formulas, but it's always more powerful and useful to understand them. Once you've done that, once you've made some sense of it, let's move on and we can try these examples. So I've put the formulas down there in the bottom right, and let's see what the question is. Example 1, determine the reference angle for each of the following angles. The angle 165. If you think about 165, you should know it's in quadrant 2, and you could actually do the formula just like it is. We know that we're going to be doing this one, okay? The reference angle must be 180 minus the angle we've been given. So the reference angle is 180 minus 165. And so our reference angle is 15 degrees. If you want to make a sketch for that, it's very simple. You just draw your original angle, which is going to be somewhere over here. And then we know that our reference angle has to be the rest. And then you could probably figure out that 180 minus the piece that we're given leaves us the reference angle, which is why our formula works. I recommend you try B yourself. All right, take a moment, pause the video if you need to. I'm going to make a little sketch for it. 230, I know, is down in this quadrant there. So it's quadrant 3. It's going to be quadrant 3. The reference angle is going to be just this piece here, the remaining. So I take my big angle and take away the 180. So for quadrant 3, It's our angle, take away 180. You should be able to see that from the diagram, but if not, you can just use the formula. The formula I'm using right now for quadrant 3 is this one. That gives 50. Okay, same thing for C. Pause the video if you need to and try it out. 300 is in quadrant 1. The formula for quadrant 4. Of course, it's quadrant 4. In this case, our formula, reference angle, is 360 minus the angle given. That's 360 minus 300, which means that our angle is just 60 degrees. I'm going to check it with a little diagram. The angle 300 is down here somewhere. That's our normal angle. Our reference angle is the smallest angle to the closest x-axis, the acute angle. So in this case, we have our big angle, we have our reference angle left over. And why do we take 360? Well, it's a full turn. Take away all of this piece. If we take all of this away, we're just left with the acute angle. So 360 minus the angle we're given, it leaves us that little chunk. For D and E, let's see what we have. Negative 45. Same basic idea. We should probably draw it to see what quadrant we're in. Negative 45 is down here. Okay, and in this quadrant, it says we're going negative 45. But a good tip for this is for reference angles, it's quite difficult to work with negatives. You'll end up getting confused. So I'm going to say change negative 45 to a positive angle by adding 360. It'll do the exact same thing, okay? It'll give us an angle that we can work with though, which is much nicer, okay? So 360 minus 45, or negative 45, plus 360, that's 315 degrees. And then we can use our rules, okay? We're going to use our rules to the right. So our angle here, 315, but really what we care about is that this is in quadrant 4, and our rule for quadrant 4 is that we have our reference angle equals 360 minus the given angle, so 315. In this case, 360 minus 315 is 45 degrees. And that shouldn't come as too much of a surprise because our angle here is 45. You know, negative 45, this negative 45 is exactly equal to the reference angle, but it takes extra understanding to get to that point. It's much safer to do that first step where you change it to a positive angle. All right, so let me separate these. I would recommend that you try E yourself. All right, try E before I do it. Give that a shot. See if you can get it. All right, pause the video and see. I'll make a little sketch for this. Negative 150 is down here somewhere. Negative 150 is actually this angle, but I'd rather go from the positive x because then our rules will work. So negative 150 degrees plus 360. That gives an angle of 210. Okay, 210 degrees, and this is quadrant 3. Quadrant 3, this is our formula that we use, okay? So our reference angle is 210 minus 180. Or in other words, our angle is actually 30 degrees. And why does that work? Well, because we go to the nearest point, nearest x-axis, I should say, and that'll give us that reference angle. So if this is 210, if this big turn here is 210, and I want to take away this 180, minus 180, we're left with just the 30 degrees. That's why this works. Okay, that's it for today's video. There's lots to think about, which is why I gave you a chance to give it a shot. All of these should be done for homework. To check your work, make sure that you understand these concepts because we're going to be building on these concepts as we go along. So please try them. I'm going to write out my answers now for them, and you can check them against your work. Anywhere that you have trouble with, anything that you need re-explained, please make a note of the page and the question number, and I'm really just more than happy to help you out with this. No problem at all, you just got to let me know. So here are the answers. And here we go, these are my answers. Please pause the video, take time to pick through them, see what I did, I want to make an important note here, a couple important notes. You don't need to draw the pictures, all right? You don't need to draw the sketches. If you know right off the bat which quadrant it's going to be in, then it's up to you whether or not you're going to draw it, or you can just use the formula directly. Finally, something that you hopefully noticed by now, but if you didn't, I'll tell you directly. Reference angles are always positive. Doesn't matter what way we measure them. Doesn't matter if we go clockwise, counterclockwise, it makes no difference at all. They're always positive. So that's why you're always taking a number minus a smaller number. Anyway, don't worry about why it's always positive. Just know that no matter what you spit out for the reference angle, it's got to be plus. All right. That's it for this lesson. I hope you learned something. I hope it didn't blow your mind too much. Take time to work through all these problems. You know, do them over again with a blank page if you need to until they really sink in. And if you've got these fundamentals, then what we move on to will be much more easy for you. Have a great day, and I'll see you in class soon.